Welcome back, guys. So let's start where we left off yesterday. Yesterday we were trying to debug the directory parsing, and we managed to find the little bug where we were just parsing the entire directory extent as normal directory, which is not the case. We'll have to initially check the correct modes and confirm whether it's a directory or a file, and based on that we are supposed to actually um, do the parsing. That is what we figured out yesterday, so let's continue today and hopefully we'll be able to get the directory parsing working. Yeah, other than that, yeah, I guess the intro is still the same. We are still working on our VFS layer and writing our own kernel, and this layer should help us to dynamically load multiple user processes that we can run, because we are done with our scheduler, we are done with our memory management, we have the user space and the kernel space. So it's just VFS layer. So yeah, let's continue with that. Okay, so yesterday when we finally ran the code, as we see, this is the root node's raw bytes. We are able to parse everything. We have the directory entry, we have the inode. So every time we go inside a node, we should also be able to go further by trying to recursively read the inode and then keep going. So that is what we do here. So the initial directory is 12. No, the initial directory is 11, and we found this directory inside the initial directory, and we further parsed it, and it worked fine. And the next directory was 13, and we tried to read this. We got an error. We fixed that. The error was just that we're not supposed to read symlinks. The actual directory was a symlink to another directory. So initially we are supposed to read this format. So it's the current mode, and only if it's 4000 we are supposed to continue. That's why we added this extra condition. And then we finally added some extra return statements in other recursions to make sure we interpret this return 0 and keep stopping that, things like that. And then we finally ran the codes, and we have two different print messages to confirm things. That is that the current mode of the directory, in this case, is some 41,000 number. And then for the next directory, it's just 0, which is why we are not supposed to read that as a directory, which is a symlink. 0 as in we are trying to mod it with 4000, that's why we got 0. No, even the current mode value is 0. Yeah, so that was the issue. So we need to figure out why the mode value is directly 0. Probably that means we are doing something wrong. So yeah, let's start with that. So I was thinking we can just take this entire log. This is where we take the log. So it's here, and now we can proceed. And why is that? Okay, let's see what is the issue, because I believe in general we are supposed to actually read something here, because value after modding can be 0, that's fine, but the value that we read for the current mode, which is the data plus 0th offset, that seems to be 0, which is odd because I'm not sure exactly sure because first time when we do it, which is for the first directory, we do have the proper value, and as you can see the mode was 41471 and the check is 0, so that's fine. But for the next directory the entire mode is 0, so probably either we are reading, so the offset cannot be wrong because it is working for one of the directory. So definitely we have something here in our buffer which is either not the proper directory, or maybe it's completely different like what we faced yesterday, because as I mentioned, if it's a directory entry we are not supposed to do anything. No, if it's not a directory entry we're not supposed to parse things directly, and we're supposed to actually properly figure out what is the file type and do further things. But here, because this is an inode, it should definitely have a mode value. So yeah, let's see. So as you can see, we had the initial directory which is 11, and it is a directory, so it's fine. And then we have 13, which is not a directory because we had a different value, and we checked for this bit and it just said 0, so we stopped there. And then okay, so that is just explaining our initial fix. So right now we are not trying to parse the symlink, we are just simply returning 0 here, so will not crash. That is the entire idea. So after that, so what exactly is this? So we have this initial directory that's parsed, and then we have the bin, which is the second directory that is also parsed because it has a proper mode. And then we have boot, which did not work because it reported 0. And then we have dev, which also didn't work. And then, but as you can see, we know that we know for sure that these are directories, and we are getting a mode value of 0. That means it's definitely wrong in our side. Something is wrong in our side. So let's see. Oh, what? Okay, so looks like anything in group 0 seems to be working. The moment we uh, move past the first group and we go to the second group, but that shouldn't matter because I notice a number, and yeah, we look up this address, this index within an inode table to actually get the physical block of this inode. Maybe that's the issue because I remember, so it's like a table. Okay, so yeah, here it is. So we have the inode block table, and what function is it? So it's the inode to number. So here, what we do is that we take the global groups and we figure out the current group. What's the current group is just temp, which is the initial bytes, into size of current group. Okay, and then we have the current group and current groups inode table. So every group, as I said, we have the physical bytes, and the physical bytes are divided into multiple groups, and every groups have multiple blocks. And to know within a group what exactly is the block or which inodes belong to which group, we have this relative indexing rule. Also, every groups have its own inode table. Is it every group or is it inside GDT? I forgot about that. Yeah, we need to maybe confirm that because right now that feels a bit fuzzy. Because what I remember is that we have a global table and also tables within. Okay, I believe we do have that. Let's just double check that. So if we go into our layouts, this is the standard group. This is how a group should in general look like. Only the first group will have GDT and every other group will have an inode table. Yes. And we should be able to index the relative index. So if inode is 8193, that means it belongs to group 1, but within group 1 it will have a relative index of either from something from 0 to probably the group size or the number of blocks within the group. So that's the relative index. So we get the inode table, probably we will be, yeah, we have the relative index here. So within the inode table, we will be using the relative index to index it. And only if it's inode table block 0, what the fuck is that? Okay. Only if it's 0th block, then we increment the buffer size, which is just this, because if it's a 0th block, then we have some padding to account for. If not, it's just we have the initial buffer, which must have been read from this inode table block. Okay, it's all looking fine. And then once we have the data, we index the values using the offsets. Okay, that also makes sense. That means probably the issue here is either we have the wrong relative index. If we have a wrong relative index, it is possible that we have a different data. Even if it is different data, probably it should not have just zeros. So that could be the second case, second issue. The most important issue must have been that I have the wrong inode table block number, or I have the wrong current group, because either this line is wrong or this line is wrong. So if we just debug these two lines, we should have some idea of what's going on. So instead of reading through what Claude is giving, let's just try to see what could have happened. Let's just bring this logs back and see what might have happened there. Okay, let's print it. I was just testing with a local LLM. I would wrote my own mini inference server. Can take any GUF files and you can run it. It was really interesting. Okay, let's just bash build. And if we manage to run it, let's kill it. And let's go to the top. So we have the initial inode as inode number 11, which is working fine. So when we come here, we should have current group as 0 and relative index as 12 and inodes per group is 8192. Okay, that's fine. And then we are trying to get the inode initial global pointer and the groups within it. And then we are also trying to get the group. But for the first case, it's because it's group 0. The table also starts in the same location. Okay, let's move on to the next value. Here we are in group 1 and relative index is 0. So we are reading exactly 8190th bit index. Okay, fine. And the table is actually different because as you can see here, the table was 58944 and the table is different. So in some way, it is different. And the block number of inode is 0. Maybe that's the issue. So because here, right now, we got the block number as 0. And if the block number is 0, we are just saying incremented by 1 to 4. I guess this is the issue. Maybe we have to check two things. Let's see. Let's also add, say, group equals 0 and inode table block is 0. Only then let's increment it. Let's try this just to be, maybe this is the issue. We don't know. Let's try. No, it didn't work. So as you can see, we still have the same number and we have the inode block as 0 and the mode is still 0. And probably right now we did not increment this because for sure inode table block is also 0, but then the group value would have been 1. And inode table block, what is that? It's the block number. Inode table block is 0. We are actually reading the 0th block, which is definitely wrong. Maybe what is, for sure it's not possible. It should not be 0 because the 0th block is, and block numbers actually increment across every thing. So it's definitely not supposed to be 0. Maybe that's the issue. So how do we parse this? That is what probably we'll have to figure out today. Okay, so everything in group 0 works, everything outside of okay, see, even here they're saying the same thing, the relative index arithmetic. So 890 is 0. Math found the right slot, just took the long block. As I said, I guess that's the issue because here we have 0. Maybe the issue is that we also maybe probably have to increment the group or the entire table parsing was wrong. Oh, fuck. So looks like we just didn't parse everything. Okay, let's try up to 8 groups. See what happens. Still no good. Still we have the same issue. We have 8193, which is returning 0, which is wrong. So this is how our loop works. And this is the actual issue, because right now we are just reading the 0th block, and 0th block is not supposed to have anything, and it's definitely wrong. So we just have to so as I said, it's definitely not the case, because block 0 is not supposed to have anything. Okay, looks like we have lots of issues, but that's fine. We can go through one issue at a time. Okay, looks like we have to fix 3 things. We need to delete the number of groups to 1, which is fine. I guess we currently just moved it to static 8, but probably we are already reading the entire group number here, but that doesn't matter. Let's just keep it static as 8 here, and then fix the writer's pointer arithmetic. What the fuck that means? Looks like we need to read everything. Okay, let's check it out. So inside file and line number 571 has nothing. We just fucking hallucinated. Who knows? But let's just figure out where we are defining the group's pointer. It must be somewhere here. Mm, size, yeah, here it is. We have the groups, and we are k-mallocking something. That's just the entire initial allotment, so that shouldn't be the issue. Are we doing any casting? Search for it. Group. Okay, here it is. So once we pre-allocate every groups, now we take one group at a time. So we just allocate a block of um, data, so block of memory. So within that, we get pointer for a single group per iteration. So every iteration has to have one slot. That's fine. And that slot is supposed to it's the same issue. We're just not casting it properly, but then the brackets are here, so I'm casting it here. Okay. Here, because this is ext4 group pointer, when I add it, we are just adding pointers. So probably it's just incrementing 64 bits at a time. No, it's probably incrementing the entire size of this groups or something like that, whatever it is. But if we try to cast it as uint 64 first, but my idea was that because groups is a pointer, because we are probably going to get a uint 64 here, and we are already casting it as x4 pointer, and then now we need to go, yeah, because we are allocating the entire size number of group times. So we take the groups, which is the base address plus size of this. How come? Because this is just a pointer plus this number should have worked. I guess if we cast it, then we'll have an uint 64. Uint 64 plus this size will have actual size. I don't know. Let's just fix this one line and try it. Let's see what happens. This was the same bug we fixed yesterday, but it was in another location. Looks like it fucking worked. So now we have the initial directory, which is 11, which was just working. And then we have the next directory, which is 13, which is a symlink, so we leave it as it is. And then we have the third directory, which is 8093, and we have the proper inodes. And now we can see it is 16384, which is in directory. And we got the proper directory, and we got the match. And then the next index. So everything works. Ah, that's good. That feels good. But let's just maybe let's also fix that issue where let's remove this completely. Let's just take things dynamic. Okay, even now it worked just fine. So we were able to dynamically get the links, the number of groups too. So only thing that we fixed is again the same. We had to cast this as UN64 first and then increment the size. But my idea seemed also just fine because my idea was just that because this is just a pointer. Pointer is probably just a value because but compiler assumes it has a x4 pointer. Probably that is the issue. I'm not sure. Hi, hi. Good, good, good. How are you? Hope you're good too. So it's the same issue. Last time we fixed it somewhere else, but right now here we have the same fix. It's just we have to cast the pointer as UN64 first and then increment the size. And then the moment we do that, we are able to parse everything properly. Okay. Now we are able to go into every directory. I think we have one more thing, which is we have to uncomment a block. Okay, wait, let's see what other issues we have. Maybe we will fix that too. We removed the group. Now it's dynamic because we removed it and it's already taken here, so it should be fine. I guess we added that just for testing purposes. And then we have the writer's pointer issue, which is here. We first had to cast it and then fix it, okay? And then turn, I guess it's just suggesting us to do that because I don't, but it does not matter. Let's keep it as it is. It's just suggesting that if the table, inode table says it's 0, then we're just supposed to stop because it does not matter. Fix the group count division to round errors. What is this? Let's see. Okay, we have it. It is part of super block. Super block is UN32 value, and we are able to get the inode size. Size of the inode, okay. And what do we do with it? We seem to be parsing it somewhere. Okay. We have the initial base pointer, and then we have empty bytes, and then we have the size, whatever it is. But the suggestion was that fix the group count division. What's that? Okay, so there's two issues inside mount x4. Where's mount x4? Okay, this is a mount x4, and we have number of groups. Where is that? Okay, number of groups and inode size. Is the integer division. The last group is almost always partial, so we have I have no idea. Probably it's just saying that we have some rounding error, but I don't understand what that is. We have the block count, which is a 64-bit value, and we have the number of groups. Okay, I guess it's just saying that. I guess I'm assuming that it is stating that we will, if we just directly do this division. No, no idea. Okay, whatever. Oh, okay. So the second issue is that we are only supposed to read unit 16, but in this case we are reading unit 32, and only because it just happens to be in our case the S block has 0, that's why we didn't get any error. I mean, let's just say block here. We are reading even 32 instead of even 16. This could lead to wrong node size, inode size. Fix this. Okay. But I believe we can, maybe let's also just say, maybe think about this operation to this might be wrong in some cases. We could get rounding errors. As causing, leading us to, that could lead us to missing certain blocks. Okay. In case if we face something like this in the future, then we'll know where to debug. So instead of just fixing it, I guess there's no point in fixing it because right now it's just working fine. Other than that, everything should. How many group descriptors fit into this one block? Group the base walk off and into unmapped unrelated. It looks like there's another issue here too that we might need to think about, but it's fine. We'll think about it later. Now let's go back to our function. Let's just run it once more just to see it work. It's working perfectly. We managed to parse 6 directories. Maybe we can increment that to where is that? Let's see, 26. Where did we define that? I'm pretty sure we had some limit. Okay, now we have to uncomment this and fix that. But before we do that, we need to remove one thing, which is okay, parse node is 8. Let's see, let's increment that to 250. We can parse up to, let's say, 50. Okay. If we do that, what happens? Okay, we reach some issue somewhere. That's some other day's issue. So let's just keep it to 10 as of now. Let's also write a comment. Fix this constant and debug the issues again. Okay. Let's see. Okay, even with 10, we are still able to parse things properly. Okay, that's fine. So let's just now see what we can do, which is just to enable this dynamic parsing. So what we are currently doing is that, let me just show you the code. Okay, here it is. So this is recursive directory parsing. So what we do is that we get the current count. What's the count value? I guess it's the number of entries. And then we get the physical block. And then we parse that. Now we try up to 128 directories. So we take the first directory and we explore that tree. Okay, that is fine. So the issue is, in case once we are done with the specific directory, let's say we are already inside bin. So we are inside root and we are able to print every directory. So this everything currently that is here is just a directory within the roots, and we are able to print the information about it. And we are also able to check the actual inode of those directories. That is where this is, because here once we have the inodes, that is example, let's say within root we have the bin and we have the bin's inode, which is 11. Now we just recursively explore inode level, which just means we convert inode 11 number into an actual inode struct, and within that it might have multiple directories, and we get all those directory entries and we have the block result. Now we have to pass that block result, which is just I blocks, multiple I blocks, to the actual recursive directory parsing. This is where we actually convert that I block into actual directory entries. That's the this parsing where we just say if the file type is certain thing, then we can actually read the first. It's like we can read the inode number and stuff like that. We can just get into it and see. Yeah, we get the physical block and we try to parse it as a directory entry. And once we have parsed it as a directory entry, then we know it is a directory and we can go into every directory. So it's just the entire recursion. So we're calling it again. So let's see what happens. Okay, after a point, somehow it failed. Yeah, failing after what? That's the question. So we parse every directories and then we are trying to explore 11 and we got the inode and we confirmed that it is a directory and then we checked it. Now we are going inside bin. That's this recursive directory parsing. So within that we have the initial dot and dot dot, which is just every directories are supposed to have it. And within that we again have exploring 13, or maybe within bin there's nothing. That's why we came out of it and we started exploring 13. It's possible. I'm not sure if that directory has anything in reality. We can double check that later. Okay, let's go into this case, the third directory. Here we have the it isn't directory, we confirmed it and we checked the thing and we actually get into that iteration. And here we have something else. We have a completely different error. This is just completely wrong here. I need to think about this picture again. So let me just recall what this is. So we have the initial root. That's the root inode. We convert that into an inode struct. We parse that inode structs inode block into block results, which is this. And then we pass the block result to recursive directory parsing. In that, every result will have a physical block, as I said, because as you know, as inode will have a physical block. And if we read that physical block, we'll get the content within that content of the directory as the content of the actual directory itself. So once we have that, we can further parse that as directory entries. That's this thing. So parse it as a directory entry. So here, this is where we actually do the directory node stuff. And then and then we can, so that is also fine. Okay, so as I said, we have the root inode, we convert it into an inode struct, and then we take the inode structs inode block, and we convert that into block results, and we pass that block result to recursive directory parsing. So we have the block result. Maybe we can write it again. We have inode. We get the inode number of this. Convert that into inode struct. Take the inode structs inode field, iblock field, which is raw bytes, parse it as extends, then and we get the block results, which is just struct in our exam, in our implementation. Now we have block results. Each is just a physical block containing the actual output of inode, actual bytes of the inode. Now we can further parse this bytes, this raw bytes, as directory entries. So this is the final parsing. Here, if we parse it, we'll get actual directory node entries. And what will a directory node entry have? Let's check it. So it's just a directory node will have the inode number and the file name and the actual, yeah, that's it. So extend directory node entries. This will have the file name and a number. So now we have the root node. We got the inode struct. We got the iblock. We converted into block results, and block result gave us the physical block. Now we got the bytes from the physical block, and we further parsed it as directory node entries. Now we have the directories that are inside slash, which is example slash root, that is slash bin slash etc, etc. So now we can recursively parse slash bin etc. So that's the case. So once we have the directory entries, we go through every directory entry, we have the directory nodes, and we pass it down to explore tree recursive. So explore tree recursive is just 9 nodes. So again, we are going to start from here, because here we have initial input is just an inode. So we started here for the roots, and once we are actually inside this root and we got the bin, we again come back and we do this entire step. So, and currently this step is also working. But once we explored the bin directory, so we were inside root, we went into bin and we explored the bin and we got the block results. Block results are actually supposed to give us the physical block numbers of those internal directories within bin. Now we try to do recursive directory parsing. This is where things seems to be not working. So we have to figure that out. Now the issue is we are able to parse the able to get the block results of the internal directories. But directory extends, something is going on. Okay, this is a scenario. We just have to figure out what this is. But at least today we managed to, as you can see, we started from here, which is the empty raw bytes, and we converted everything into directory entries, which is bin, boot, dev, etc. And then we went inside one directory, which is the initial directory, that is bin. And inside that we have two directory, which is dot dot and dot dot. And then we try to explore the next directory, which is probably boot. And when we try to go into it, we are getting an error. So this is what the current scenario is. But overall, we are able to properly at least go one step into it. And I believe it is working because, as you can see, that when we try to parse inode 11, which is bin, we got into it and we saw two directories within it, which is just dot and dot dot. So it is definitely working. And then we have 13, which is the second directory, which is okay. 13 is not, we are not supposed to go inside 13, right? Because 13 is the symlink. And I have the continue statements. So we shouldn't have gone inside it. See, yeah, for that we didn't go, and then we started the recursive tree for 8193, and for that it is a directory, so we went into it, and then we got the physical numbers, which is 8615, and then it didn't work. Okay, that's fine. That's fine. At least we have a little bit of better understanding of a better picture of what's happening here. I think this picture should be enough for us to try further tomorrow and maybe find something better. But actually understanding how we parse one, but understanding that we are always starting from root is really interesting, because no matter what directory it is or what path you try to explore, we are going to start from the root path, because that's the only static inode you always know. Probably the actual Linux implementation would have multiple cats. So whenever we try to explore a node, it might have already catched its inode and inode struct. So we don't have to keep parsing it every time, because in my case, if I have to go to a different directory, I'll always have to start from roots, go explore all the directories within it, and see if the path matches that directory and go within that. We haven't yet implemented that cases, but right now, because we are just exploring every directory, because we listed the initial root and we have like let's say 10 directories. We go through every 10, we again list it, and we keep going until there is nothing more to explore, so that we will have the entire picture of the file system. That was the key idea here. And the final example that we wanted to explore was /etc password. So we want to read password file, but we don't even have the file implementation. So far, it's just directory entries. And if we face anything else, currently it's just written 0. Yeah, so yeah, let's continue this tomorrow and see how it goes. But overall, we managed to move a little, make a little progress today. Yeah, that's good. Thank you guys. I'll see you tomorrow then.